Okay, in this video we're going to do a brief review of differentiation. So we'll go through a couple of the derivative rules and then some applications. So the derivative of a constant is going to be 0. The derivative of x to the n, that's the power rule, will be bring down the exponent as a factor and subtract 1 from the exponent. Derivative of a product of functions. So derivative of f of x times g of x will be equal to the derivative of f times g of x plus f times the derivative of g of x. Derivative of f of x divided by g of x is going to be g of x times f prime of x. So sometimes we say that's low d high, minus f of x times g prime of x. And then high d low, all over low squared, and of course we're assuming that g of x is not 0. Okay, so that's your quotient rule. And then finally we have the chain rule, which is f composed with g of x. Derivative of that is going to be f prime composed with g of x times g prime of x. Okay, so we're going to do a couple of applications of these. I think we got 4 of them illustrating these different rules here. So go ahead and speed this up a little bit. So find the derivative of each and simplify. So the first one we're going to look at is f of x is equal to 3x to the 5th minus 2x squared plus the square root of x minus 6. And we're going to go ahead and rewrite that square root user-friendly. So there shouldn't be the prime there. So let's go ahead and erase that. So we're not doing derivative just yet. Okay, so f of x will be equal to 3x to the 5th minus 2x squared plus, remember square root is the same thing as the 1/2 power, so that makes it a little bit more user-friendly to do the power rule, and then minus 6. So the derivative is going to be 3 times 5, x to the 5 minus 1, or 4, minus 2 times 2, x to the 2 minus 1, which will be 1. Bring down the 1/2, x to the 1/2 minus 1 is negative 1/2, and the derivative of the minus 6 is going to be 0. So we can simplify that down a little bit. So that's going to give us 15x to the 4th minus 4x squared. And then we can rewrite the 1/2 power, because our negative 1/2 power is going to go at the bottom, and we can write that as a square root. Okay, and that's pretty much as simplified as we can get there. I guess you can get a common denominator, but this is good enough. Okay, so that is illustration of the power rule, and then a derivative of a constant. So we're going to go ahead and look at another one. And for reference here, we're going to go ahead and put the chain rule up again. Alright, so here we're going to look at f of x is equal to the 4th root of x to the 5th minus 3x squared plus 11. So this is a composition of functions, so if we want to fit the chain rule, the outside function is going to be the 4th root of x, or we'll write it as a rational exponent in a minute, and then the interior function, or g of x, will be the x to the 5th minus 3x squared and plus 11. Again, x to the 4th root of x is x to the 1/4 power. Okay. All right, so f prime of x, bring down that 1/4 power. So here we are taking the derivative of the outside function. So 1/4 power, whatever the base is, and then subtract 1 from that 1/4, and that'll make that a negative 3/4. Okay, so there is your f prime. This is the f prime part, and then the argument, and then here is your g of x in the interior. Now the other thing we need to do is multiply by the derivative of g of x, which will be 5x to the 4th minus 6x. Okay, the last thing we can do is we can go ahead and simplify this so we don't have that negative exponent anymore. So we have 5x to the 4th minus 6x divided by 4, and then we can write that as x to the fifth minus 3x squared plus 11, and then moving that exponent down will make that positive to the 3/4 power. Okay, so there's just run of the mill chain rule problem, and we're going to do some little bit more advanced problems. We're going to do one with the product rule and chain rule, and then quotient rule and chain rule. So number 3 here, we're going to look at 4x squared times the square root of 5x minus 1. So we have two functions here. So the derivative of the first function being 4x squared, so the derivative of that will be 8x. Leave the second function alone, and we're going to go ahead and we're going to write it more user-friendly as 5x minus 1 to the 1/2 power. So there's the first part, and then plus that first function, 4x squared. Then we're going to take the derivative of the square root of 5x minus 1. So you're going to bring down the 1/2 exponent. 5x minus 1, subtract 1 from the exponent. That'll make it a negative 1/2. And then the derivative of 5x minus 1 is 5, and that's your chain rule going on right there. Okay. So we've taken the derivative. The next thing to do is to go ahead and clean it up, make it look a little bit nicer. So what we're going to go ahead and do is we're going to write each term, figure out what the greatest common factor is, and then we'll factor that out. So I'm going to write both terms. So we have 8x times 5x minus 1 to the 1/2 power. And then if we simplify, 4 times 1/2 is 2, and then times the 5 at the end there, that'll make it a 10x squared. And then 5x minus 1 to the negative 1/2 power. All right, so first thing we'll do is we'll look at the numbers. 8 and 10, greatest common factor there should be 2. And then the x in x squared, common there is x. And then the 5x minus 1, we always go with the negative exponent or the smaller exponent, so that'll be the negative 1/2. Okay, so when you're factoring out, that's the opposite of distributive property. So when you're doing the distributive property, you're multiplying. When you're factoring, you're dividing. You're doing the opposite. Okay, so we're going to factor out a 2x times 5x minus 1 to the negative 1/2 power. And so we'll go ahead and do an example here. If I have b to the 1/2 divided by b to the negative 1/2, what you do when you divide like bases is you're going to subtract your exponents. So what you're going to do is that's going to be b to the 1/2 minus negative 1/2. And so that is going to make a b to the first power. So over here, if we simplify that down a little bit, 8 divided by 2 is 4. The x's will absorb, and we have 5x minus 1 to the first power, just like we have here. Okay, now we'll do the same thing with the other term. 2 into 10, 5 times, x into x squared, x times, and then the 5x minus 1 to the negative 1/2. Those will absorb. Okay, so our derivative will be equal to 2x and then 5x minus 1 to the negative 1/2. That's what we factored out. And then 4 times the quantity 5x minus 1, and then plus 5x after we've done the factoring. We'll go ahead and simplify that down. And the 2x will still be there hanging out in front. And then we can simplify down there 25x minus 4, and then all divided by 5x minus 1. You can say under the square root, you can say to the 1/2 power. Doesn't matter. You could also, I guess, distribute that 2x if you wanted to. Probably this form's a little bit nicer because then, you know, we can do easier applications with the derivative by, you know, setting that equal to 0 if we're trying to find, you know, your critical numbers there. Okay, we're going to go ahead and look at one more. It's going to be kind of nasty, but if you can understand what's going on there, then you're good with your quotient rule and chain rule problems. So we're going to look at f of x is equal to the sine of 3x. And so if you don't remember your derivatives of your trig functions, go ahead and practice that. Sine of 3x minus the cosine of 2x, and then that's going to all be under the fifth root of x squared plus 1. So first thing we'll do is we'll rewrite it so that the fifth root on the bottom is now a 1/5 power. And we'll go ahead and apply the chain rule. So it's going to be the low function, x squared plus 1 to the 1/5 power, and then times the derivative of the top. Derivative of sine is cosine, so it'll be cosine of the argument 3x. Derivative of 3x is 3, so there's your chain rule. Okay, and then minus, the derivative of cosine is negative sine, so we'll have to subtract minus sine of 2x, and then we get a 2 by the chain rule. So there's your low d high, and then minus the high function times the derivative of the low function. So times the derivative of the low function, bring down that 1/5, x squared plus 1, subtract 1, and that'll be negative 4/5 as the exponent. And then the derivative of x squared plus 1 is 2x by the chain rule. All over the denominator squared. Okay, and so we're going to play a similar game with doing the factoring. There's not a whole lot we can do with the trig stuff here, so we're gonna leave that alone. But we will worry about the x squared plus 1 to the 1/5 or negative 4/5 and the fraction there. So we're gonna focus on those terms there, and the trig stuff. There's not a whole lot we can do with it. So we got x squared plus 1 to the 1/5 power. And then we got the 2x over 5, x squared plus 1 to the negative 4/5. So we're going to only focus on that stuff. There's not much we can do with that trig stuff there. Okay? So we're going to go ahead and see what we can do. I don't like the fraction, so I'm going to factor out a 1/5. And then I have x squared plus 1, and then the lower exponent is negative 4/5. So that's what we're going to factor out. Okay. All right, so when I divide by 1/5, you're dividing by a fraction, so you flip it over and change it to multiplication, so that becomes a 5. And then we're going to have, and then over on the other side, the 2x over 5 divided by 1/5, that'll be 2x. B to the 1/5 divided by b to the negative 4/5 will be equal to b to the 1/5 minus negative 4/5, and that'll be b to the first power. So likewise, we will have x squared plus 1 to the 1/5 divided by x squared plus 1 to the negative 4/5 will give us x squared plus 1. Okay, on the other fraction there, the x squared plus 1 to the negative 4/5 will absorb. All right, so f prime of x is going to be equal to 1/5 x squared plus 1 to the negative 4/5. That's what we factored out. And then we have 5 times x squared plus 1. And then that'll be 3 cosine of 3x plus 2 sine of 2x minus 2x times sine of 3x minus the cosine of 2x, all over x squared plus 1 to the 2/5. Okay. The last thing we can really do is we can go ahead and migrate the 1/5 and the x squared plus 1 to the negative 4/5. We can move those down. Okay, so the top will be this giant mess. I guess you could distribute stuff through, but it didn't really look like anything would really happen there, so I'm going to leave it alone in its complete messy form there. All right, so just barely enough room to write this all down. And then the denominator, there's the 5 from the 1/5. And then it's x squared plus 1 to the 6/5. So that's about as far as we can go. So certainly if you're looking for more examples, check my YouTube channel. I have some other videos of, chain rule and product rule and quotient rule. And there's plenty of other excellent videos out there. So really this is meant to be a real brief review. Here's a couple of examples to kind of get you familiar with it again. Because we really want to be good with our derivatives in Cal 2. All right, so that's it for this one.